Can you find the LCM of these numbers in your head quickly? Let me know with a comment below. We'll come back to this question later. There's a lot to learn before that. Hey there and welcome to Massific Aptitude. In this video, we'll learn how to find LCM and HCF, something very important as far as aptitude tests are concerned. And you'll not just learn how to find the LCM or HCF, but with the tips and tricks you learn in this video, you can find the LCM or HCF for a set of numbers quickly with no or minimum use of pen and paper. And that is important for at least two reasons. One, the ability to work with numbers in your head is like a superpower. It gives you a mighty advantage over those who don't have it. Two, LCM and HCF are very important concepts. In addition to the questions based directly on them, you'll be using them all the time while working with questions from other areas, like fractions, ratios, percentages, work and time, and more. So if you want to do well on an aptitude test, you better master the concepts of LCM and HCF. So, let's get started. And if you're new to the channel or have not done so yet, do subscribe and click that bell icon. That way, you'll be notified whenever I post a new video to help you ace your aptitude tests, CAT, placement tests, or any other for that matter. Okay, let's begin with what we mean by HCF, or the highest common factor. And for that, we'll use this table. These three columns contain the complete list of factors of 12, 24, and 30 in descending order. The factors of 12 are 12, 6, 4, 3, 2, and 1. And then we have these for 24 and 30. Now, as you can see, there are a few numbers common to the three lists. We have 6, it is a factor of 12, 24, and 30. Same with 3, 2, and 1. So these are the common factors. And 6, being the largest among them, is the highest common factor or the HCF. It is also known as the greatest common factor or the greatest common divisor. So HCF is nothing fancy. Just as the name suggests, it is the highest common factor. Alright, with that, it's time to dive into the real business. How to find the HCF for a set of numbers in your head. So, find the HCF of 12, 24, and 30. These are the same numbers that we just worked with. Now, here's what you do. You take the smallest of the given numbers, in this case 12, and then you go through the factors of this number one by one, starting with the largest. What is the greatest factor of 12? It's 12. Greatest factor is always the number itself. To check whether this factor is the HCF, you need to check whether it is a factor of the other numbers too. Is 12 a factor of 24? It is. Is it a factor of 30? No, it isn't. So 12 cannot be the HCF. Remember, to be the HCF, it must be a factor of every number in the set. Okay, with 12 out of the way, we move to the next largest factor. The next largest factor of 12 is 6. Just divide 12 by 2. Again, we check whether it is a factor of the other numbers too. Well, 6 is a factor of 24. 6 times 4 is 24. And 6 is also a factor of 30. 6 times 5 is 30. So, 6 is the highest common factor. It is a common factor, and because it is the first common factor that we found while working our way down from the top, it is also the greatest or the highest common factor. So again, to find the HCF, go through the factors of the smallest number one by one, starting with the largest, and as you go through the factors, check if they are factors of the other numbers too. The first number to pass the test is the HCF. Now, as is the case with most mental methods and techniques, it appears to involve a lot of work. But what you must not forget is that once you give yourself some time and practice, the steps become internalized and you start to do it all in an autopilot mode without even being consciously aware of the different steps. So, it's important that you learn with an open mind and give yourself enough practice. Alright, the next example. Find the HCF of 8, 16, 40, and 60. In this question, the smallest number is 8. But before we start working with its factors, there's a trick we can use to make our work easier. If you look carefully, 16 and 40 are multiples of 8. 8 2s are 16 and 8 5s are 40. And so any number that is a factor of 8 will also be a factor of 16 and 40. Remember, factors of a number are also factors of its multiples. So we don't need to check whether a number is a factor of 16 or 40 separately if we have checked for 8. What that means for us is that we can ignore 16 and 40 while finding the HCF of these four numbers. And so we just have 8 and 60 to work with. Okay, 8 is the smaller of the two, so we'll be working with the factors of 8. The largest factor of 8 is 8 itself, but it doesn't divide into 60 evenly, so it cannot be the HCF. The next largest factor of 8 is 4, and it is also a factor of 60, so 4 is the HCF. So the takeaway from this example is that if you see one or more numbers that are multiples of some other number on the list, feel free to ignore them when finding the HCF. Just like we ignored 16 and 40 because they were multiples of 8. Alright, next example problem. And this time we have larger numbers: 60, 120, and 270. Now in this example, I want to show you a trick that helps make the numbers smaller and hence easier for us to work with. The idea is that when finding the HCF of a group of numbers, we are free to divide each number by a common factor. Here, it is easy to see that all these numbers can be divided by 10. There are other common factors too, like 30 or 5. Take any common factor and divide everything by it. You don't need to worry about which factor to choose. The idea is just to make the numbers smaller by division. Let's go with 10 here. So we get 6, 12, and 27. Next, we use what we learned earlier to find the HCF of these numbers. 6 is the smallest number here. Now, 27 is not divisible by 6. So let's try the next largest factor of 6, 3. And 3 can divide each of these numbers evenly. So, 3 is the HCF of 6, 12, and 27. But we were asked to find the HCF of these numbers. And for that, all we need to do is multiply this HCF by 10, the factor that we removed earlier. 3 times 10 is 30, and so 30 is the required HCF. So don't be intimidated by larger numbers. Very often, you can make them small by using simple tricks like this one. And you can use this trick if you need to find the LCM too. I'll show you an example when we get to the LCM part. Anyway, here's the next problem. Find the HCF of 190, 210, 245, 250, and 375. What do you do with this one? Well, 190 is the smallest number, so you can start with the factors of 190. Or you could divide all of these numbers by a common factor, maybe 5, so that the numbers become smaller and easier to work with. But there is a smarter way. You see, the HCF is not just a factor of the numbers in the concerned group, but also of the differences between any two of those numbers. So, the HCF here will also be a factor of 20, the difference between these two numbers. Or 35, if you take these two. We can take any two of these numbers and the difference will be divisible by the HCF. But you might be thinking, how does this help us find the HCF? Well, if any two of the given numbers are close to one another, like 245 and 250 in this case, then it becomes very easy to find the HCF. Let me explain how. We pick any two of the numbers that are close together, preferably the closest to one another, and we take their difference. So in this case, we take the difference between 250 and 245, 5. Now, as I mentioned earlier, the HCF must be a factor of this difference. So we need not look for the HCF beyond the factors of 5. The greatest factor of 5 that can divide each of these numbers will be the HCF. Now, the greatest factor of 5 would be 5 itself, and it does divide each of these numbers. It's simple. They all end in 5 or 0, and as such, they are all divisible by 5. So, 5 is the HCF. How easy? So just look out for any two numbers that are close to one another. Take their difference and go through the factors of that difference looking for the HCF. This trick can be very helpful at times, especially when working with larger numbers. And now, to conclude our discussion on how to find the HCF, we have this last example. We are asked to find the HCF of 24, 48, 40, and 29. Just one look at this list and one can say that the HCF would be 1. Can you see how? One of the numbers, 29, is a prime number. And as such, it has only two factors, 29 itself and 1. So the HCF must be one of these. Clearly, 29 is not a factor of the other three, and so 1 must be the HCF. So the takeaway is that if there is a prime number on the list, the HCF will either be that number if it divides all the others, or it will be 1. If there are two prime numbers, the HCF must be 1, because two prime numbers do not have a common factor other than 1. Okay? And I'll take this moment to suggest that you familiarize yourself with the first few prime numbers, at least up to 50. You should be able to quickly recognize a prime number when you see it. In several ways, it helps you get better with numbers. Alright, those were a few tips and tricks on how to find the HCF. What follow are tricks on how to find the LCM. First, a quick intro to LCM. Here's a table listing the multiples of 4 and 6. Now, just like we had common factors, here we have common multiples of these two numbers. We have 12, 24, and 36. And there would be more if we make this list longer. Unlike a list of factors, which is limited and finite, a list of multiples is endless. You can keep going higher and higher. And so, we don't have a greatest common multiple. Instead, we have the LCM, or the least common multiple. 12 is the smallest among these, and so it is the least common multiple, or LCM, of 4 and 6. Now let's see how we can use this understanding to find the LCM of a set of numbers, starting with these three: 3, 4, and 10. Here's the working rule. You take the largest of the given numbers and go through its multiples one by one, starting from the smallest. It's like the opposite of what we do for the HCF. In this example, 10 is the largest number, and the smallest multiple of 10 is, of course, 10 itself. So we start with 10. But as we go through each multiple in our heads, we need to check whether they are multiples of the other numbers too. Remember, we are looking for a common multiple. So, is 10 a multiple of 3 and 4? No. You can just divide and check. 10 is not divisible by 3 or by 4. So we reject 10 and move to the next multiple, 20. Now, 20 is divisible by 4 but not by 3. So 20 also gets rejected. Similarly, 30, 40, and 50 will also fail the test because they are not divisible by both 3 and 4. But the next multiple, 60, is divisible by both. And so, 60 is the LCM. We just check to make sure it is a common multiple, and because we have tried every multiple of 10 before that, we know it is the least common multiple, or the LCM. So again, start with the largest number and go through its multiples one by one until you find one that is also a multiple of the other numbers. That's all you need to do to find the LCM. Let's look at the next example, and with it, the next trick. Find the LCM of 9, 15, 18, and 30. Now before we start working with multiples, we'll use a trick to make our work easier and quicker. Among these numbers, if you observe carefully, you'll see that we have 9 here, which is a factor of 18. 9 times 2 is 18. As such, every multiple of 18 will also be a multiple of 9. And so, if we are checking for 18, we don't need to check for 9. We can ignore it. Similarly, 15 is a factor of 30, and so we don't need to check for 15 when we are checking for 30. It's very similar to what we did with the HCF, but with one important difference. When finding the HCF, we ignore the multiples, and when finding the LCM, we ignore the factors. Keep that in mind. Okay, so now we have 2 fewer numbers to worry about, and 30 is the larger of the 2 that remain. So let's try the multiples of 30. The first one would be 30 itself. But 30 is not divisible by 18. And so we move to the next one, 60. 60 is also not divisible by 18. And so the next multiple, 90. Now 90 is divisible by 18. 18 times 5 is 90. So 90 is our LCM. Now the next example is just to demonstrate what I mentioned earlier, that you can take out a common factor even when finding the LCM. In our example here, every number is divisible by 50. So we remove that common factor from each of the numbers. 100 divided by 50 is 2, 150 by 50 is 3, and these would be 4 and 7. And now we just need to find the LCM of these smaller numbers, and then we multiply that LCM with 50, the factor that we removed earlier, to get the required LCM. Now, what is the LCM of these numbers? We can ignore 2, it is a factor of 4. What remain are 3, 4, and 7. Their LCM would be equal to their product. How? That's a trick for the next example. For now, we'll just proceed. 3 times 4 is 12, and 12 times 7 is 84. So the interim LCM is 84. Multiplying 84 by 50, we get 4200. This is the LCM of the numbers here. Alright, here's one final trick before we conclude this video. Sometimes we need to find the LCM of two numbers that have no common factors. For example, 5 and 7, or 11 and 15. In such cases, the LCM is simply the product of the two numbers. So, 35 and 11 times 15, 165. And this idea can also be extended to cases where you have more than two numbers. You must just make sure that no two numbers have a common factor. Like in the previous example, we had 3, 4, and 7. 3 and 4 don't have a common factor. Same for 4 and 7 and 3 and 7. So the LCM would be the product of the three numbers. 3 times 4 times 7, 84. Another example of such a case would be 3, 10, and 11. Again, no two numbers have a common factor, and so the LCM would be their product. 33, 330. Okay, now that we have covered everything we wanted to cover in this video, it's time for the problem we started with. How do you find the LCM of 4, 16, 11, and 5? Well, 4 is a factor of 16, so you can just ignore it. Now 16, 11, and 5. No two of them have common factors. So the LCM would be their product. 5 times 16, 80, times 11, 880. That's all. It took me about 15-20 seconds here because I was explaining along the way. But it's not difficult to do all this in about 5 seconds once you get the hang of it. Remember, practice and patience hold the key. Alright, with that we come to the end of this video on how to find the LCM and HCF. I hope you liked the tips and tricks and found them useful. If you did and would like to help me and others, just like, share, and comment. And of course, don't forget to subscribe. It all helps me bring more useful content for you. And you might also want to watch the other video on solving problems on HCF and LCM. The link is there in the description. Alright then, until next time, have fun, take care, and keep learning.